find the exact value of the trigonometric function at the given real number. So the exact value is going to be a place on the unit circle. So when it says find the exact value, we are going to be finding the corresponding point on the unit circle. It would be, but don't worry, you're not going to be able to do that. Okay, so we have the sine of 2 pi over 3. So the first thing that we're going to do is we're going to find that on our unit circle. Okay, so for 2 pi over 3, okay, I'm going to separate it so I can think of it as 2 times pi over 3. So 2 times I'm going pi over 3 units, which remember pi over 3 is 60 degrees. So when I count, here I am at 1 pi over 3, here I am at 2 pi over 3. Okay, so at 2 pi over 3, I have found where I am on the unit circle. So that's your step 1. Okay, so find the value on the unit circle, which I'm going to call UC. Okay, once you find where it is, then the next thing you're going to do is use your reference angle. So from your homework last night, you guys should have noticed a pattern. Okay, if your angle is someplace on the unit circle, what was your reference angle? So like for 2 pi over 3, what's our reference angle? Pi over 3. Okay, for negative 4 pi over 3, what's our reference angle going to be? No, it'll always be positive, but yeah, pi over 3. For cosine of 14 pi over 3, what's our reference angle? Pi over 3. For negative 3 pi over 2, what's our reference angle? Pi over 2. For the 5 pi over 4, what's our reference angle? Pi over 4. So as long as it was on the unit circle, one of our special points on the unit circle, the reference angle, when you split it apart, would be right here. Now, that didn't work when we had like pi over 7, right? If you had something pi over 7, it wasn't always pi over 7. All right, so if it's on the unit circle, it'll be right there. So like I said, the first quadrant we need to have memorized. So we should know at pi over 3, we have 1/2 root 3 over 2. Because this is in quadrant 2, okay, we are going to adjust point to the quadrant. So in quadrant 2, my x value is negative, my y value is positive. So that means I have negative 1/2 root 3 over 2. And then I can see what I'm looking for. So I'm trying to find the sine of 2 pi over 3. So this is my x and this is my y. The sine is what coordinate? The y. So sine is the y coordinate. So this is my y coordinate, which makes the sine of 2 pi over 3 equal to root 3 over 2. Okay, now I wrote out all that work to show you. Okay, I know some of you are more fluent in the unit circle and you'll be able to determine that a lot quicker, and that's perfectly fine. Okay, I'm just doing this to show you how you can reason your way through it without having the unit circle in front of you. Okay, to just look at it and see, which is probably what you did in Algebra 2. Okay, so now we're kicking things up a notch. So now we're going to do negative 4 pi over 3. I'm also going to show you another strategy. If any of you are having trouble like counting, like, oh, how does she know where to put the tick marks? What you can do is you can put all of the tick marks on your circle It goes 1, 2, 3 for 30, 45, 60, and that continues around the circle. So if you wanted to do that and then circle when you count, you could do that. So for -4 pi over 3, I know pi over 3 is the third dash. And then if I go another 60 degrees, this would be 30 degrees and 30 degrees, so that would be 60. Then here's my next 60. So I have 1, 2, 3, and then here's my fourth one. So this is where I am at -4 pi over 3. Okay, so at -4 pi over 3, we're actually at the same point where we were before. So we're at -1/2 root 3 over 2. That's the same thing that we had here, okay, in quadrant 2. So now I'm trying to find the tangent. So we know that the tangent is going to be y over x. Jeez, overheats. Okay, and then so here's your x, and then here's your y. Okay, so then your tangent is going to be root 3 over 2 divided by -1/2. Okay, and then we'll skip, flip, multiply. The 2's will cancel, and you will be left with -√3. Now, once you start thinking about C, the cosine of 14 pi over 3, how do I know that's more than one full rotation around the unit circle? Yeah, say that. Okay, so we know that 6 pi over 3 is a full rotation because 6 pi divided by 3 is what? 2 pi. Okay, so we know that would be one full rotation. So if I did a second full rotation, where would I be? Yeah, 12 pi over 3. Okay, and again, that's because if I went around twice, I'd be at 4 pi. 12 pi over 3 is 4 pi. Or you could just do 6 pi over 3 plus 6 pi over 3, which is 12 pi over 3. So I'm going to do those two rotations first, then I'm going to count. Okay, so if I have 14 pi over 3, then I just have to do this as 12, 13, 14. And look, it's our same friendly point again. Okay, so at 14 pi over 3, our point is -1/2 root 3 over 2. And that all comes from the work that we did in the first one. Okay, so this was our reference angle, and then you switch it to the quadrant. Okay, so we already did that. And now we want to find the cosine. Okay, so the cosine corresponds to what coordinate? The x coordinate. Okay, so this is my x coordinate. So the cosine of 14 pi over 3 is -1/2. Okay, so the cosine is the x coordinate. Okay, and then for D and E, we have the cotangent and the secant. So we have a couple reciprocal functions. So I'm going to start, this is -3 pi over 2. I'm going to find where that is on the unit circle. So pi over 2 is how many degrees? Yep, 90. So I would go 1 pi over 2, 2 pi over 2, and then here I am at -3 pi over 2 at the top of the circle. What's my point at the top of the circle? 0, 1. Okay, so I know that my cotangent is equal to x over y. So if my point is 0, 1, here's my x, here's my y. The cotangent of -3 pi over 2 is going to be 0 divided by 1. Can we do 0 divided by 1? Just 0, right? 0 divided by 1? Yep. When is it undefined? zero's on the bottom. Okay, so undefined would be a possible answer. Okay. Okay, so your cotangent for that one be 0. So now we're going to do the secant. So the secant is 5 times pi over 4. Okay, so pi over 4 is 45 degrees, so I'm going to go 1, 2, 3, 4, and again, you know that this is pi, so that's like 4 pi over 4. So now I have 5 pi over 4. So this is in quadrant 3. So the first thing that I do, okay, because we haven't done the pi over 4, think of your reference angle. If your reference angle is pi over 4, at pi over 4, I know I'm at root 2 over 2, root 2 over 2. So if I'm adjusting that for quadrant 3, where both the x and the y are negative, I know it's negative root 2 over 2, negative root 2 over 2. So for the secant, you can think of that a couple of different ways. Okay, so the secant is 1 over the cosine, or 1 over x, or it really just is the reciprocal of what? It's the reciprocal of the cosine. So I can take the cosine value, the cosine of 5 pi over 4 is negative root 2 over 2, which means the secant is negative 2 over root 2. So they're reciprocals, right? Okay, so you have negative root 2 over 2. You're going to flip that to 2 over, or negative 2 over root 2, but I can't leave it like that, right? So what do I have to do? Yeah, multiply by root 2 over root 2. Okay, so then I'll get negative 2 root 2 over 2. Can I cancel anything out here? The 2's on the outside only. Okay, so then your final value would be negative root 2. Okay, and
are we going to get this little table on our quiz? I don't know.
Definitely not. Okay, so then the next thing we're going to do is we're going to be given a terminal point. And that's just determined by an arbitrary real number t. We have to find the sine of t, the cosine of t, and the tangent of t. So with these, it's really, it's simple to calculate, but make sure you have them in the correct notation. So the first point is negative 5 over 13, negative 12 over 13. And then I have root 5 over 5 to root 5 over 5. Okay, so if you got ahead of us, just make sure you get down A and B now. So remember that this is x and y. Well, the sine is the y coordinate. So the sine of t is just negative 12 over 13. Okay, that's the y coordinate. The cosine is the x, which is just negative 5 over 13. Okay, so if that's our y and that's our x, then to find the tangent, you just have to do y divided by x. So when I write this out, what I do is write it horizontally. So negative 12 over 13 divided by negative 5 over 13. So then I can skip, flip, and multiply, or multiply by the reciprocal. And in this case, the 13s will cancel each other out. I have negative 12 over negative 5, but a negative over a negative is a positive over a positive. So we would write that the tangent of t is equal to 12 over 5. guys are writing this out, just notice, do I just have the sine equals negative 12 over 13? Or do I have something next to it? The sine of t. So this is kind of like a log. You know how when you put the log in your calculator, a parenthesis always pops up? Because you have to have the log of something? These functions are the same. So if you were to type in sine into your calculator, a parenthesis would automatically pop up because the sign has to be of something. Okay, so if you don't know what it is, you can call it x or you can call it theta. Okay, and in this case they told us it was t. Okay, so for part B, did you guys already do your sine and your cosine? Right, so your sine of t was 2 root 5 over 5 because that's your y coordinate. Your cosine was root 5 over 5. Okay, and then to find your tangent, you would do your y, 2 root 5 over 5 divided by root 5 over 5. Okay, so we're going to skip, flip, and multiply. And what can be canceled out here? Okay, so the 5's and root 5 divided by root 5, so I'd just be left with 2. So the tangent of t would be equal to